fully effective discharge outlet, and mass flow. For mass flow to occur, the discharge outlet of your storage bin must be fully effective. What I mean by that is that during discharge, material must empty equally and evenly from the full length and width of the discharge outlet. And whether this is a reality or not has everything to do with the behavior of the feeder. In principle, this is an easy concept to understand, but it is one that designers often get wrong. And when you get it wrong, the consequences are terrible. You see, usually when you are designing a storage and feed system to empty in mass flow, you are doing so for a reason. Number one, because you want the first in, first out discharge pattern. Or number two, and this is a critical one, because the minimum geometry, specifically the minimum discharge outlet required to reliably discharge your bulk solid in funnel flow is too big. It's unworkable. Whereas the minimum discharge outlet required to make mass flow work is much, much smaller and more reasonable. And when I say that you're designing for mass flow for a reason, is because a mass flow storage bin is typically more expensive than a storage bin designed to empty in funnel flow. A mass flow storage and feed system requires steep hopper walls and sometimes a low friction liner. None of that is cheap. If the discharge outlet of the storage bin is not fully effective, you will not get mass flow. It does not matter how much money you spent on that bin. It doesn't matter how steep the hopper walls are. It doesn't matter that you are using a fancy low friction liner. None of it matters. You will not get mass flow. Imagine that you have a mass flow storage bin. What happens when you cut off the flow from any portion of the outlet? Immediately, you get stagnant material along the bin walls, and you have material flowing on material. What I'm describing is not mass flow, it is funnel flow. Remember the definition of mass flow. With mass flow, the entire mass of material in the storage bin comes down as a single body. All of the material in the storage bin is in motion. And the indication that you have mass flow is that material is sliding on the bin walls. In contrast with funnel flow, material shears through itself. Material is sliding on material. And the indication that you have funnel flow is that material is stagnant on the bin walls. As soon as you interrupt the flow of material from any part of the discharge outlet, the flow pattern switches to funnel flow, regardless of the bin geometry. This has huge implications for slide gates, clamshells, belt feeders, apron feeders, and standard augers. When you interrupt the flow, you get funnel flow. And for difficult flowing materials, this can be death, as you likely won't be able to get reliable funnel flow discharge in a storage bin designed to empty in mass flow. To learn more about why bins plug and the theory that underpins good bin and feeder design, visit the KamengoU website and download our white paper.